So this is a continuation of the lecture to the working of the rectifier with an RLE load. Now we are going to do the analysis. For that purpose, we have to write down the KVL equation for this particular circuit. So it is Pm sin omega t is equal to R into I naught plus L into d I naught divided by dt plus E. Now the solution to this equation has basically two components are there. One is the steady state component and another one is the transient component. So a steady state component will be there, another one is the transient component will be there. And this steady state component, it is sum of actually two components, that is nothing but IS1 plus IS2. So IS1 is due to the source voltage Vm sin omega t, and IS2 is the one which is due to the DC counter EMF E acting alone. So IS1 can be written as Vm by Z sin omega t minus phi, and IS2 is being found out by thinking that only E is present, so therefore I can write IS2 as minus E by R. Minus is because it is in the reverse direction. And the transient component of the current IT is given by A e raised to minus R by L into T, which we have already discussed in our previous sessions. So therefore the total current I0 is nothing but IS1 plus IS2 plus IT. So it is Vm by Z sin omega t minus phi minus E by R plus A e raised to minus R by L into T. So this I'm writing it as equation number 1. So now you need to find out the value of A. The value of A is being found out using the boundary condition. So that is at omega t is equal to alpha, your I0 is nothing but 0. That we can be seen from your curve over here. So therefore you will be getting your value of A, and by substituting that you will arrive at the final value of your current I0 is equal to Vm by Z sin omega t minus phi minus sin of alpha minus phi into e raised to minus R by omega L into omega t minus phi minus E by R into 1 minus E power minus R by omega L into omega t minus alpha. So this is for the period from alpha less than or equal to omega t less than or equal to beta. So the extinction angle beta will again be depending upon the EMF E, firing angle, and the load impedance angle phi. Now we need to find out the average load current and your average output voltage. So your average output voltage V0 is given by E plus I0 into R. So your average load current I0 can be obtained from your integrating the waveform of I0. So it is I0 is equal to 1 by 2 pi R into, from where to where? It is from alpha to beta Vm sin omega t minus E d omega t. Now by integrating this system from alpha to beta, you will be getting it as I0 is equal to 1 by 2 pi R into 2 Vm sin alpha plus gamma by 2 into sin gamma by 2 minus here. So this gamma, it is being obtained by substituting beta is equal to alpha plus gamma. So this is the final equation for I naught, and this is the equation for your voltage V naught. You can also substitute the value of I naught over here, and you can expand the equation of output voltage V naught. So with this session, we have completed the entire things of half-wave control rectifier with resistive load, with RL load, and freewheeling diode, and RLE load. So we have to understand how we can draw the waveform at each point of time, what is happening, how the source current and output current is varying. So it has happened only in the case of the freewheeling diode action. The rest of the things, the output current and the source current both were the same. Thank you.